Dye penetrant testing for surface cracks, including a comparison with magnetic particle testing. A knowledge floater from Karl Deutsch Wuppertal with videos, animation and audio. Introduction and motivation. Dye penetrant testing is ideal for detecting not only surface cracks arising during the production of engineering components, but also gas pores that develop during casting and may cause problems during mechanical machining. Penetrant testing is a relatively simple procedure. Its full name, dye penetrant testing, makes clear how it works. Red or yellow fluorescent dye is applied to the surface of the material. It penetrates by capillary action into any crack that is open to the surface. The visibility of the process is enhanced by the so-called developer, which provides a high contrast due to its white color. The testing procedure is carried out in 6 steps. The area to be tested must first be thoroughly cleaned. Next, the dye is applied by a brush or a spray can. The dye penetrates into the crack by capillary action. For personal and ecological safety reasons, testing should always take place in a spray wash cabinet with exhaust facility. Excess dye is cleaned off. And the developer is sprayed on. After drying, the developer draws the dye out of the crack, making the defective area more visible. The exact location of the crack becomes visible within a few minutes, as shown here in quick motion. The procedure ends with final cleaning and completion of the final documentation. Here, 2 examples of dye penetrant testing. On the left, dye is being applied with a spray bottle onto a large crankshaft. On the right, the bearing seatings of a motor block are being tested. Dye is being applied with a brush. For ease of handling, the heavy motor block is placed on a turntable. Comparison of dye penetrant testing and magnetic particle testing. Although the working principles of the 2 test procedures are entirely different, capillary action and distortion of magnetic fields, there are certain similarities. In both cases, the testing agent is applied as a fluid onto the component surface, and in both cases, the pattern of a crack becomes visible on the component surface. Furthermore, inspection and evaluation is in both cases generally by naked eye. Therefore, the question arises, why 2 different methods are used? Are there any significant differences between them? In contrast to magnetic particle testing, which relies on the ferromagnetic properties of the material, dye penetrant testing can be used on both ferrous and non-ferrous metals, for example on aluminum and copper, as well as austenitic steels, and even on glass and certain plastic and ceramic materials. In most cases, magnetic particle testing uses a fluorescent testing agent to visualize the cracks. In penetrant testing, red dyes are normally used. Only for highly sensitive testing, also a fluorescent agent is employed. The 2 methods are compared for cracks within a welded steel plate. With ferrous metals, magnetic testing of surface cracks is clearly preferable. It is faster, more sensitive, and indicates defects in greater detail. Dye penetrant testing must be evaluated after a well-defined moment, certain minutes, after the application of the developer, because the dye tends to diffuse across the cracks, which diminishes the clarity of the indication. However, penetrant testing is relatively low cost, requires less equipment, and has the decisive advantage that it could be used to test almost every relevant material. To conclude, here once again is a comparison of the results of the two methods for a roller bearing carrying many surface cracks. On the left, penetrant testing using red dye. In the middle, a penetrant testing procedure using a fluorescent dye that is evaluated under ultraviolet light. On the right, the results of magnetic particle testing.